Hello, good evening, guys. Today I will be discussing uh, one of the most important problem from leetcode in this placement series, that is container with most water. What is the aim of this problem is that you will be given an array of height with, that is, this x comma y determines the at ith index. That particular height of I determines this height of each pole in a in some, let's say, container. Okay, in, say, this is the total bigger container which have been separated with these slabs, better to say, of different heights. So height of these slabs are the elements of the array, and what our aim is that we need to find out the maximum area uh, that the water will cover when poured in this container. Okay, say for in this example, for the example one that is given, you are given an height array with first slab having height of 1 then 8, whatever be the unit. Okay, you can consider it as centimeter or foot. Okay, whatever is your convenience. So numerically, by magnitude, this has a height of 1 unit, this 8 unit, 6 unit, 2 unit, and so on. Now, if we consider this particular example, if you would have poured water in this particular section, it would have covered an area of, say, this is of, the base is from I starts from 0. So this is I is equal to 0, I is equal to 1, I is equal to 2. Now let me write down in this paint window. So this is your index 0, then you have index 1, then you have index 2. Wait, index 2, index 3, index 4, index 5, index 6, index 7, and index 8. Okay, now, so if we pour water between index 0 and index 1, it covers an area of, because the height is 1, among the two among the two we will be considering the minimum slabs, because if we pour more water, then the result will be same, because the water will overflow this portion, right? If we are pouring water in this section, if we are pouring water in this particular section, then it will fill up to this height only, right? And beyond that, if we try to fill, beyond this height, if we try to fill, if you can imagine, then this will overflow, right? Beyond this height, the water will overflow, and so the height will be up till the minimum of the two slabs. So this covers an area of as the base is 1, so base portion is 1 and the height is 1, so 1 into 1 square unit. If we poured in this section, then the area would be 2 minus 1, that is 1, and the height is of the minimum, that is 6, so 1 into 6 is 6 square unit. And in this way, same here, so it is having a height of 2, and 2 into 3 minus 2 is 1, so it's 2 square unit. What is our aim is, we just need to find the maximum area. We need to find such two slabs there, so that the water covers the maximum area in the container. That is what our aim is. So if we consider this total section from here to here, this slab, then it covers an area of, say, from the base, if you see 8 minus 1, that is 7, and the height of the minimum one is also 7. So 7 into 7, that is why they have given the output as 49. 49 is the maximum area, right? So in order to uh, check for the solution, we can first go with the brute force approach, uh, where we can consider finding out all the possible areas that the water can cover between each slab, and then returning the maximum one, right? That is the most common solution that we can get in our mind. So just find out each area, compare it with the previous one. If it is greater than that, then store it, and consequently we will be getting the maximum area. So as per that, what we can do is we can consider, say, two pointers. Let's say first one is I, that will be having, starting with from 0, I is equal to 0, and a pointer that will be starting from ith index plus 1, right? Because why ith index plus 1? Because if we start j from the same index as I, you can see if j is started from here, then j minus I, so base becomes 0, and 0 into something is always 0, and the area becomes 0. So of course that will uh, that is the least area, and that cannot be possible. Something having an area of 0 meter, at least in this container, will never be possible, because in the constraints we will be able to see the height of I will always be greater than equal to 0, and less than equal to 10 to the power 4, and therefore, so height we consider never to be 0. I mean, not the height, or height of I can be 0, but the base side cannot be 0. The difference between the two pointers. Fine. Therefore, we proceed. So now, if we continue doing this approach, then in this way, what we will be doing? So j minus I will always be the base, and we just take the height of the minimum, or minimum height among the two slabs. So among these, this slab is having the minimum height, right? And therefore we consider this height. So if we take a variable, initially say initially say we have a variable called max area. Max wait, max area, initially say it is having some minimum value, okay, say 0, okay, because area cannot be negative, so we can consider minimum to be the 0, right? Area can never be negative, therefore we start from 0, and now j minus I, that is 1 minus 0, is 0 into the minimum of the two. So the area that we will be calculating each time, that will be j minus I, right? Because the base is j minus I into whatever will be the minimum among height of I and height of j. Let me drag it. Height of j And if because if this area is greater than the previous max area, then max area will be assigned with this value of this area variable. Okay, consequently we will be reaching the maximum area. So in this case, first max area, because the area becomes 1, because 1 is minus 0 is 1, and so 1 minus 0, and into minimum of these two is 1, so 1, so area becomes 1. So is the value of area greater than the present max area? And so of course it is yes. Therefore we store in max area the value of area, that is 1. Okay, fine. Similarly, when j is equal to 2, j is equal to 2, in that case, in that scenario, so 2 minus 0 is 2, and the minimum among, this is this height and this height. The minimum among these is, of course, height of I, that is having a height of 1. Therefore, uh, 2 into 1, that is 2. So present area becomes, area is equal to, area is equal to 2 minus 0 into 1. So that is equal to 2, and max area is equal to, so is 2 greater than the previous max area? Yes, it is. So therefore we stored area in this variable. Similarly, when j reaches index 3, j is equal to 3, in that situation, again 3 minus 0 is 3, and the minimum of this is 1. So therefore 3 into 1, again 3. Right. So at the first pass, if we do any iteration, uh, uh, wherever we pass j, you observe one thing: 3 minus 0 into 1, so that is equal to 3, and max area, again it is of course greater than the previous max area, so it is 3. Okay. If you observe, this is the least height we are having, right? Therefore, we are no more proceeding with pass 1. In the program it will be compared with each of the heights, right? But every time this will be the minimum, because this is having the least height among all the slabs, and therefore always we will be multiplying something with 1, and that something will always be greater than the previous value. And consequently, when j reaches at index 8, right, so I am writing, so say so on, and at the first pass, right, at the first pass, when j reaches 8, okay, when j reaches 8, j is equal to 8, and this is our first pass. First pass, first pass means I is equal to 0. Okay, actually what we are doing in the brute force approach, we are first considering keeping one slab fixed at a time, and then comparing with all the other slabs, right? So area is equal to, when j is equal to 8, it is 8 minus 0 times 1, that is 8, that is equal to 8. And the max area will be definitely 8, because in this pass that is the maximum highest value we are having. Okay, you can do this comparison with a pen and paper at your home, right? And you will get to see that at the first pass max area will be 8. Okay, And now similarly, at the second pass, when I is equal to 1, when at the second pass, when I is equal to 1, then in that case, so now I points here, okay, I actually. So for the second pass, I'm considering a separate row. Say this is where I points, I is equal to 1, and j starts from 2. Of course, j will be starting from I plus 1th index, because the previous uh, slab of course has been compared with I is equal to 0. Okay, so in this case now, again let us say, and at the beginning of the second pass the max area is 8, right? At the beginning of second pass max area is 8. Now see, area is equal to, so j minus I, that is 2 minus 1, into minimum of height of I and height of j. So height of I is 8 units and height of j is 6 units. So minimum is 6 and therefore area is 6. So is it greater than the previous max area? The answer is no, and therefore we won't change max area, and max area stays 8 only. Max area stays 8 only. Fine. Now again, when j is equal to 3, j reaches index 3. J reaches index 3. In this case, 3 minus 1, that is 2, and 2 into minimum of these two heights, so that is 8 and 2, of course 2. So 2 into 2, let me write it down here, area is equal to j minus I, that is 3 minus 1, into minimum of the 2, that is 2, that is equal to 4. And but max area, is it greater than the previous max area? Answer is no. So max area remains 8. Again, when j is equal to 4, j is equal to 4. Now, among these two, the minimum one is 6. I mean, sorry, not 6, 5. It's coming around this line only, 5, line number 5. Okay, let me draw. If you consider this is the height, right? So, yeah, so it is 5, and so 5 into 4 minus 1, that is 3, 15. Area is equal to, area is equal to 5, I mean, sorry, 4 minus 1 into 5, that is equal to 15. And is it greater than the previous max area? Yes. And therefore we assign it to max area. Max area becomes 15 now. Fine. So in this way, if we go for j is equal to 5, among 8 and 5, 5 will be the minimum. I mean, height of 5, sorry, height of 5, that is 4. 4 will be minimum. And 4 into 5 minus 1, that is 16, will be in the new max area, right? So 16, max area turns out to be 16 in next iteration. When j is equal to, your j is equal to 5. Similarly, when j will be 6, so definitely it will be 6 minus 1, 5, and 5 into 8, that is 40. So 40 will be again stored at j is equal to 6. j is equal to 6. At j is equal to 7, at j is equal to 7, at j is equal to 7, just imagine it here. J is equal to 7, j is equal to 7. 7 minus 1 is 6, and 6 into 8, that is 48. So 48 will be stored here. Max at j is equal to 7, at j is equal to 7, and secondly, when j is equal to 8, so max area will be among these two. When j is equal to 8, actually I have done some mistake. This is j is equal to 6, right? So very sorry. At j is equal to 6, it will be 6 minus 1 5, and 5 into 8, it should be 40. It should be 40 in this stream. Wait, 40. This should be 40. Okay. Just a sec. And this will be 6. At j is equal to 6. 6 minus 1 5, and 5 into 1, that is, if 5 into 8 is 40. Okay. So my bad, please don't consider. Okay, those are silly mistakes that happen. J at j is equal to 7 now. 7 minus 1 is 6, and 6 into 3, that is your 18. And 18 will definitely not be stored. And similarly, when j is equal to 8, this will be 6. 6. And at j is equal to 8, when j will be 8 and I is 1, so 8 minus 1 is 7, right? 7 into minimum of these two is 7, so 7 into 7, 14. So I hope you got this idea. Consequently, when I will be 2, there will be no such area where you get the, I mean, where which will be greater than 49. You can test it at your home. This is your assignment. You can take a pen and copy and do the dry run for other passes, the third pass, fourth pass, fifth, and of course I will also go till eighth pass. I mean, yeah, for zero, that is for seventh pass. And similarly, it will have 7 into 7, 49 iterations. Okay, so we can let us consider writing the code now. What we will be doing, we can calculate in this way. Say we need two pointers first, that is I and j. So int I comma j. And how will it run? So I will be running from 0 to the size of this array, that is your height size. Height size is your size of the array, that is given here. Height size. Okay, I am considering writing this code in C programming language. You may try writing this in Python or whatever programming languages you know. If you know any other, then you may try in that also. So for I is equal to 0, I less than height size I plus plus, and j will be starting from what to say, I plus 1th index, right? I plus 1th index, I plus 1, j less than height size j plus plus, right? Now what we will be writing? Now what are we doing basically? And we will be taking a max area variable name called max area, which will be initially 0. Okay, that is the least highest height we can assume. I mean least area that we can assume, right? And for the area we can calculate it like this. Say first of all, the base area is nothing but the base size into the minimum height among the two slabs. So among the two slabs, if we consider the minimum, first is base j minus I into the minimum. So I'm writing a function called min that may return, that is going to return me the minimum of the two heights, right? So minimum of the height of I and height of j. Okay, so I'm writing this min function above. This minimum will be calculating, say it has two parameters, num1 comma num2 into num2, and it will be calculating the minimum. So what can we write? So basically if num1 will be less than num2, in such case it will be returning, because if num1 is less than num2, then num1 should be returned because it is the minimum among the two. Otherwise it will be returning a num2. In other programming languages, you also have library functions for finding the minimum of two numbers. You can use those, right? Otherwise you can write a function like this for finding the minimum. Fine. And now, so area is this, and what we will be doing, if this area is greater than my present max area, then max area will be storing this. Max area is equal to area, and finally we will be returning our max area. Fine. So yeah, that's all. This is our brute force approach. Fine. So if we run this, it should give the correct output. But this solution, yeah, it is accepted in all the example test cases, but this is not an acceptable solution, right? Why I am showing you. Now when I submit this code, just see what error it is throwing. It is throwing an error called, it is not actually an error. Um, what to say? It's and time limit exceeded is itself a term. It is used because the time, see, if I go to the description of the problem, the height length, that is the n, is between 2 and 10 to the power 5, right? 10 to the power 5 means it's 1 lakh. Okay, now the code that I have written, in the worst case, the time complexity of this code is, this is where the importance of time complexity comes. The time complexity of this code is big O of n square. big O of n square, right? And space complexity that actually I have not discussed yet, but just for now, know that space complexity is 1. Okay, in this program, space complexity is fine, but the time complexity is big O of n square. That means what is happening for a huge array like this, where you have around 1 lakh elements. The total length of the array is 1 lakh, maybe. Okay, if the height size is given. Uh, if the array size is 1 lakh, so we are actually running for 1 lakh into 1 lakh approximately. So 1 lakh time 1 lakh, I mean 1 lakh times 1 lakh, that is 10 to the power 5 times 10 to the power 5 is 10 to the power 10 iterations it need to perform in all total, and so many comparisons, right? So 10 to the power 10 operations become hectic for the machine, and of course it takes time to give the output, but these coding platforms, these are not given that much time to for the code to execute, right? That is why it is called competitive programming. Your machine should run your code. You should write such an algorithm that should that the machine should be able to run in that specified amount of time. Fine. So in the next upcoming video, I will be bringing up optimized approach for this uh, container with most water problem, that so that we can get rid of this time limit exceeded problem. Okay, so thank you guys, that's all for today. Stay well.